Morning, everybody. So, this is parts to that Volvo L220 that I'm working on. Depending on what part of the country you're from, you probably either would call this a Z-Link or a bell crank. But anyway, it's what transmits the power from the tilt cylinder up to the bucket. So anyways, it's got some pretty womped out holes in her. I don't know if you can see the clank and rattle, but she's pretty bad. But it's got a strange problem that I don't really know how it happened. But anyway, this is two pieces. And it's got a bushing that goes all the way through this end that ties the two halves together. Well, somewhere, disassembly or something, this thing has got misaligned. I'll spin you around so you can see it from this end. So as you can see, the two halves are not in line with each other now. And I'm trying to figure out how to get them lined back up because I still got to do a test weld on this and see if it's iron or if it's cast steel and whether I can weld it or whether I'm boring and sleeving. But at any rate, I've got to get the two ends of this thing lined up with each other, and it's going to be a bit of a challenge. I've already set her up. You can see I've got her teetering here on a couple of corners, and I first off tried beating on it with my big dead blow. That didn't do anything. So then I give her a few good cracks with that. That also didn't do anything. So I'm afraid that what I'm about to have to do here is take this sucker. I got the hydraulic press. I'm sure I can figure out how to do it in the press. I just don't want to have to do it in the press. So it's going to be some screwing around to get it in here. But I think that's the stage we're up to. So I'm going to screw around and get her finagled in here. And I guess I'll bring you guys back when we start stomping on it and see how she straightens out once. All right, everybody. I'm going to show you this. So I ran me a little bead with a MIG gun right there. I ran it right down the parting line in the casting. Anyways, let me show you this. See that? She ain't even scratching her. So, it's definitely ductile iron. Now, I know there's a lot of you guys out there that are going to tell me just get your nickel wire out and weld it up and all that baloney. And I'm just going to tell you, it ain't a good idea. There's two reasons I dislike that immensely. First off, I've had a couple of times welding on ductile iron where despite two passes, she pulled enough base metal up into the welds just, if you're getting good penetration, it means you're mixing base metal with filler metal. Anyways, where I got her sucked up into the top of the weld enough that I still had hard spots even after two passes. The real issue, though, is that it really ain't sticking that well. I don't like the idea of cutting this thing out and having a half-stuck hunk of nickel wire inside that hole. And then where it really gets ugly is if some poor sucker comes along later and they've got to come in there and cut that thing out and try and do something with it. You got some pretty hard spots at the transition zone that are going to give them just holy fits. So I pretty much have shied away from that and just try to stick with boring them and sleeving them when I run into this. So that's what we're going to set up to do, bore it, sleeve it, and get it back to the customer as quick as possible. So I just proved my point with that little weld. I'll grind it back off, make it look pretty, and we'll get on with life. Try throwing a plate across here. You can see the rock in it better now. Get a better feel for how bad out of square she is. I know Press didn't even flinch. I beat on that thing. She wouldn't even think about moving. Well, hydraulic press just gives her the good old squish and away she goes. I think what I'm going to have to do, just because the press frame itself is flexible enough, you can see I got quite a bit of it, but I think I'm going to have to put a spacer under this side. So that I can get it, basically I got to be able to push past, so to speak. Spacer underneath that. Oh yeah, she's pushing nice. What I've been doing, I put a few shims under already. I put a single point block here, and then I've got a clamp here, and I'm clamping, so I'm getting basically 3-point contact here, here, and in the middle here. And what I'm currently working on is, once again, I'm really limited on how to decide when this thing is truly square. This is a used bushing. They're not replacing it. So admittedly, it could have wear in it. So what I'm trying to do is, the seal is knocked out of this. I'm getting on the edge of this seal surface is what I'm doing now. And checking on each side where that seal, that's as close, or the original bore, that's the best that I can get. So I'm, admittedly, there could be a little bit of wear happening there just from sand and grit over time. But I think that's the best possible option that I've got for getting to something like square. All right, everybody. I am just doing some measuring to try and calculate out the offset between those faces so I can get this squared up. So I've scraped through the paint there and up here. I took a measurement there, 9.087. I'll have to see if that figure, well, I guess it ain't going to figure out to a nice number. It's two separate pieces and they have separated a little bit up there. But just curious what we get. This is 11.197. 197. So 2.110 divided by 2 is 1.055. So that is theoretically the offset, 1.055 between that and that. So if I, on the other side obviously, come up and touch off on those 2 points, I should be square when I hit 1.055. I'm not going to trust that all by itself. I'm going to do that, and then I'm going to try sweeping these bores and just like run it down the bores, I should say, just to see where I end up at. But that should at least give me somewhere to get started from. All right. definitely something very satisfying about machining iron. Alright, there's 50 thou on the side, eating like nothing, so we're going to roll with that. Alright, so I'm within 25 thousandths of finished bore diameter, so I'm taking a spring cut just to see. It ain't cutting a lot. This ductile iron cuts easy enough that it doesn't deflect the bar too bad, but I just want to see where I'm at, and then we'll probably dial in, I don't know, something about 5 thou on a side short of finished dimension, and take what else I need to take in 2 passes then. Alright, there's the first pass in this hole. Taking a swipe through there. Alright, well, we got them done. You can see a little bit of a counter bore in them for shoulder. They all came out real nice, so now we're setting up to machine the bushings that are going to go in there. Alright, 75 thousandths on a side, 350 RPM, and see, I gotta look, what am I at here? Yeah, I'm running 10 thousandths per revolution feed rate right now. Cooking along pretty good. ran my cutting oil on it for a bit to cool it back down. That's why we're getting as much smoke as we're getting. I do not use water-based coolants in my machinery at all. It's too bad, too rough on the machinery, so this is strictly mineral oil in here, so you get lots of smoke when you get it hot. Smoking or non-smoking, everyone? We think we'll take smoking. A bunch of oil sitting in there from when I cooled it off, and she's really smoking off as I'm cutting in there. It's my last semi-roughing pass, and then we're down to finish passes. Alright, everybody, so I have got the bore to finish dimension all the way to within, about a 1/4 inch of this end. And then the OD to dimension here, the shoulder is correct. This is the correct dimension for the shoulder counter bore. So now what I want to do is flip it around and grab it this way, because this is barely long enough to make both parts and part it off. So I want to grab it from this end, but because I've made it a lot thinner here, I don't want to have to super grab it. Now that I've shrunk it in size, I can get away with flipping my jaws around and getting on it full depth so I don't have to grab it as tight. So anyways, that's what I'm working on, but a whole bunch of these tiny little chips have got themselves into the jaws of my chuck. So not only do I have to take my top jaws and flip them, I got to take my bottom jaws and turn them around. So I'm going to go ahead and spend a little time here getting everything rearranged the way that it needs to be, and then I'll bring you guys back when I'm setting up for the next round here. Alright, that piece of paper I just added put me within half a thou total indicated run out, so we're stopping right there. Very few tools that I'm more terrified of in a lathe than a parting tool. They're just straight up little demons. Wad of chip up next to them, yank your part out. Alright, well, nothing ugly happened. I just got to face that one off, turn that one around, stick it in there and face it off, and by golly, these are done. Alright, we're started in on the next set of bushings. 100 thou on a side, depth of cut here, roughing it out. Bushing. This one still needs to get faced off, but it's basically done. And I'm just making the other one, then I'll flip them both around and face them at the same time. Anyway, we're cruising right along here. Well, we're finally done with all the machining. You see I've tapped one bushing in just a little bit to make sure I liked the way it was feeling, but that's the other large bushing, 2 small bushings. I'm going to get set up now and press these suckers in here so we can call it a night and go home. Yeah, she's going square now. I think what I'm going to have to do is just nail it and reset every time. Wimpy hits I was giving it ain't getting jabbed. So if this was a hardened bushing, you probably wouldn't be able to drive it because it'd be too resistant to compressing, but this mild steel one shrinks down relatively easy, forms the hole. You notice that are all loaded up with anti-seize too, so it's good and slippy sliding. More good swats, and that one will be in there. Oh yeah. One more ought to send her home. Probably have to hit. I just realized I'm kind of hydraulicking with the anti-seize, so I may have to smack her a few times just because the anti-seize hold me up. That felt pretty solid. Oh yes, that was it. Okay, well, there's that one. Let's just move our butt right over to the next hole over. Wipe it out good. Drop a bushing in there and hammer it home. At least I hope that's what we're going to do. Alright, well, here's when we find out how good all of my mathematics are. You're always halfway guesstimating. Not shabby. A little bit looser than what I was shooting for. It apparently didn't crush up quite all of it, but she ain't terrible. Not by any means. Alright, now, I've been discovering more and more lately that the mechanics that have to put these together don't like them near as tight as I like them. I've had a few grumbling lately when they had to tap them in. They all want to be able, and I kind of get that. If it isn't a slip fit by hand, when you're trying to get stuff aligned, the problem is with a slip fit, you can just keep pressure on it, rattle around until it goes in. If it ain't a slip fit, then you got a guy there pounding away on the end of it. while another guy plays with the controls trying to find the sweet spot. So I understand why they want them that way, but I don't like them like that. Oh yeah. Woo. She nipped me a little. Yeah, that might turn into a blood blister. It's interesting. That one, I got closer to the fit that I was actually after on that one. Yeah, I think we can roll with that. I believe what we're going to do is leave her set right there for the night. And tomorrow morning I'm going to throw that in the back of the truck. We'll go take her back to the customer so they can put the machine together. So there you have it. That's Volvo L220 Z-Link or a bell crank, bored and bushed.